Okay, we're back. I did eat. My stomach is very, very full. Yeah, so this function is being called with vector, pointer, and then never filled. Okay. And who's calling me? It's a pointer to Vertex input attribute descriptions of the class at Vertex shader. That is correct. That is never filled. Why does the thing even exist? Or am I wrong? Oh, wait a minute. It should be filled. This copy is being called. And it is called. Isn't it? Looks like it is called. Okay, it is being called, but then it says could not find, so it's not doing anything. Six times, yeah, we have 3 of these. And position in index data and position in vertex data. And texture coordinates in vertex data. And both pipeline factories are calling this. And it's not being found. Hello, LGL. Hello. LGL, no, not really. It does happen that I look at code that I wrote 10 years ago, that I think, oh my god. Because my style continuously keeps changing and I think improving. But the day after, no. Well, rewrite it, if it is that bad. You should, you should have written it like that in the first place, I guess. I can't say I'm happy with the code that I have now. It's very hard to understand. I continuously have to re-understand everything, but I blame it on my memory. Not per se that the code is bad or something. Maybe the code is so complex that it's, well, hard to maintain and understand, etc. But it would take me I would need to understand everything first, everything. So the whole program. So let's finish it and then have the whole program in my head, so I understand exactly how Vulkan works and what I want and etc. etc. Then I could write a better version, which is probably better readable. But it's not going to happen, considering how bad my memory is. Plus, it's definitely not going to happen the first time, because right now I have no idea how Vulkan works. I'm finding out a while ago. So maybe in 10 years I understand Vulkan, but the only question is how much do I really understand by then, because probably I've got 80 or 90% again of whatever I learned during that time. So for me there's only one thing really important, and that is to write code that works with a capital W, and that I have never to look at it again, because I'm gonna forget it anyway. And I don't think that's a bad way to write code. So if you wrote crap, ask yourself, did you write that code with in mind that once you finish it, you were sure that you will never have to look at it again, because it was perfect. No bugs, optimal speed, the best API that you can wish for, flexible, everything. If that's the case, then it doesn't matter how it is written, because, well, you have never need to look at it again. Which is definitely not the case with this code, because I keep looking at it because it doesn't work. Okay, so this function is being called, and then it cannot find stuff that it should find. Oh, I need to look locations. Now I'm following the wrong thing. There's locations. Standard Vertex attributes. Yeah, it's also called 6 times. It's kind of annoying, I think, that it is printing unfinished and then the found is printed here. I think I would rather have it print found before I enter this. It should be possible. Yeah, LGL. Missed saying you saying bye. Okay, so now it prints found, and then it prints entering is used in. And that is about instance data and position. It's one of the three. I see all three there. So this one, and that one, and that one. And now we call update location. And then later, or before this probably then, it said it cannot find it. Cannot find it. So that happens before this, I guess. This is at 74%. %, totally before that. Yep, so I could not find because it's much later that it is added. It's because I moved the call to this up. Vertex. God. I'm gonna call that old. I'm going to call that old, as in, why is it still being edited somewhere? I don't believe that. I don't believe that. Yep, so this must be called before that is being called. And that's bloody preprocess. Yeah, so that's why it was in preprocess. Aha. And I moved it up because something else needed it. So we have a loop dependency or something like that. But I moved it up because of what I just added. So I split the functions up in two functions. I can do it. So we have these copy functions, and then one of them is just one of them, I think. Is filling the shader variable. That's this one, and that should happen early. Okay, I don't think I need to insert in the other functions anymore. I'm just going to call copy shader variables first. And well, if it is null, I'm still going to crash. But an insert is probably never going to fire here anymore anyway. And then also getting tired of having two functions. Well, I call both of them at the same time anyway. So this one is filling vertex input binding descriptions, and the other one is filling input attribute descriptions. Just going to call them yeah, now I need to add my changed back, it seems. So maybe they should be separate, or no, I can just do it. Update, I guess. Update. Update is a better word. Let's call it update Vertex input descriptions, whatever. Both of them. Oh. They are virtual functions. Why? Yeah, okay, they're virtual functions. I'll just rename them all. Nope. And I just called updates. Totally lost now how I call them. Yeah, they are called copy, but that was not what I was using. Copy shader variables and update Vertex input description. Yeah, another problem is back. I'm calling them more often than once. So I probably need to re-add my changed booleans, and I don't know. I'll just need to see it running and failing before I understand how to fix this, I guess. Or it just works, of course. Well, currently. I think that it's still a problem, what I said. Let's run it a few times. Yeah. If you can remember that before we had sometimes it was small and sometimes certain things were away, and that's got fixed now. Yeah, pretty good. Well, let's do some boring stuff. Git maintenance. Wait. Let's see what is in here. No, there's nothing. Remove troop. I'll probably remove all of them. Just output, I think. Diff. Let's just do a git. Shall I look at git diff first? Let's rename. Oh, I did a lot of renames. Rename. That's necessary. Well, basically every change is good unless it is nonsense. Now that's interesting. I think that this is related to the changed thing. So yes, the answer is then yes, it's the right place to call it. And then if I bind something else, say for a different fill index, CQ different pipeline, but generated by the same pipeline factoring, I could call this again with a Vertex buffer that is Vertex buffers object that is different with regard to layout that the pipeline is expecting. And then maybe stuff changes. Okay, this is a bit vague, isn't it? Let fix me stay, because I don't know. Okay, more rename, and then we got more rename. Yeah, and just renaming stuff. How horrible. Yeah. Okay. Well, that one looks entirely okay. I'm just gonna add it. And I put this at the top because I added accessors. Am I using those accessors? Yeah, I should be. I'm using it here. Okay. And the other one? Yeah, it's also, I guess also. Get project sources with, and that is probably the same file then, but update vertex descriptions. What? Oh yeah, both. Okay, so look at div continued. Bug fix. So we can say that this file is also ready. No, that was a good change. This is a lot of extra debug output, which I might not need anymore. It's a bit far-fetched to say that I'm sure that I won't need it anymore. I'll just keep it. At some point I really need to make a bunch of extra debug channels though, so I can turn something off. So the vulkan channel is doing a lot of output. Okay, so I'll just add this one as well. Yeah, well, whatever. This is the same fix me. Yeah, same fix me as that one. I have to add where to call it from. Yeah. Okay. This is not correct, but I'm gonna commit it anyway, I think. all these three disappear from add vertex shader? I guess I did. I think this one went to vertex buffers. Yeah, I don't know. Also, what about this one then? That's still vertex shader. Oh, it's also still there. Yeah, okay. So that means that I can just commit everything in this file as well. Okay. Yeah, both of them, right? Time, quit, no, add this one. And this one. And we're done, finally. That was renamed, this is needed, that's extra output, why not? Let's add everything. Hey, Omnic. It's going pretty good. Yeah, look. Got this working. I'll push it for you, so you can test it. Oh, I just did. Wait a minute, let's try this. We're still on open brain surgery. Maybe I'm kind of out of that now. I feel like it's more like bug fixing, but this particular program that now runs is as far as I got before this, you know, incredible large refactoring. So I might as well get rid of the whole brain branch, I think, and merge it into master. Still have a lot of fixed miss, but not so much that I would say that the open brain surgery is still going on. It's kind of a closer skull, I think. Even. Well, you know, yeah. Yeah, these two we just looked at. Okay, that's a vague remark. Fix me implement. Okay, that's alarming. Oops. What the hell? We don't crash here. We don't crash here because I don't have an assert. Do I even get here then? We do get there. Oopsies. What the hell? Register add fragment channel. Oh, yeah, well, yeah. Oh, wait. Oh, I have a different Vertex shader, something else, and fragment shader. Yeah, dum. Not done yet, I guess. Okay, all this does is for the add vertex shader is a base class of a characteristic of a pipeline factory, which has these two vectors to fill. It's all about the vertex attributes, the vertex input stuff, bindings and attributes, descriptions for the next pipeline. Yeah, so clearly we need to call pipeline factory, add flat create info, and then some stuff. Maybe, perhaps. We'll just pass all the vectors that are declared in this object, which are none. The whole bloody thing is not doing anything. Well, I don't know. QQEW. Want to see the results? Well, drum ruffle. I know it's a bit much to take in, but that's it. Oh, I didn't recompile. Sorry. No, that's the result. Absolutely beautiful. I know. The best way to learn C++ is to start learning it. What are you doing here? Start learning it. It's amazing, but my eye is completely okay again. I'm still worried, of course. I think it might be caused by me staring at the monitor so much, so I should just have less screen time maybe. I don't know what it is, or was. Let's hope it's something that my immune system can take care of. I mean, that would also be very scary. There's a bacteria at the back of my eye or something. But at least then it can really cure. I think we have a milestone here, and I have to admit something, guys. I have to admit something. I'll bet everyone is going to leave. Yeah, see, we have 23 current viewers now. But every time I go to sleep, every time I go to bed, I read in a science fiction book first for 10-20 minutes, and then I turn off the light. And for the past weeks, like since Christmas, I think about the college conjecture. That's what I fall asleep with. I just can't help myself. So I thought I'm not going to waste any more time on it, as in coding, but I keep thinking about it. And I think this is a nice moment, the last half hour, to return to the college conjecture and, you know, do some stuff that I keep wondering when I'm laying in bed. So yeah, excuses for in advance, but I'm going to go to the college conjecture thing again. I forgot, of course, what directory that was. Should be somewhere in here, right? Nope, nobody knows. C++. Probably best if I just use a find here. Omni, can you remember in what directory my college conjecture thing was during Christmas? Christmas puzzle. That could be it. No, not really. Something else. From long time ago. Okay, name, does it have college in it? College. I totally overlooked the fact that there's a college. Still don't see it. There it is. Oh well, never mind. Okay, so yeah, basically I'm gonna code now what I've been thinking about while I'm laying in bed for a long time now. And I definitely need to, you know, have a quick verification. Let's say just generate all the numbers from 1 to a million and then verify how many steps there are. Let's begin. We are going to start again from the beginning. Let's call this one bed, because it's my bed thoughts. I want to begin with making a vector that I fill with the number of steps I'm going to use using though for the large numbers. And it's called those numbers number or something. And unsigned long. That's what we begin with. And then I'm going to make a vector with actually a till a million, yeah. So that's long is not even needed, not by far. I'm going to the number of steps that fits in an integer. Steps. So we're going to run from, let's call that k then, that's the number. K is less than 1 million, plus k, steps. So the first one, yeah, well, maybe I want to just use the index here. So let's start something with a size of 1, put 0 in it. I think I just make a size of 1 and then default constructed int will be 0. So if now I do a push back, that's index 1, that's corresponding to my k. And then I'm just putting in it the number of steps. Steps required 4k. Well, I'm not really interested in actually there must be a conversion between index and number, I'm afraid. Let's say number to index. Because I'm not interested, really not interested in even numbers. If ever proved to call its conjecture for all odd numbers, then it's also proven for all even numbers, because all even numbers have to be divided by 2 until we get an odd number. And if that then fulfills the Collatz conjecture, then so did the even numbers. So yeah, let's not do the even numbers. And then it would be kind of sad to, you know, let's say what I want to do is we have number 1 and 2 and 3 and 4 and 5 and 6 and 7 and so on. And the index that I want to use, well, maybe I want to use 1 as index, I'm not sure, but let's put that then in 0. And then I skip 2 because that's even, and I want to use index 1 for 3 and then index 2 and so on. So we definitely have to divide by 2. It's going to be n minus 1 divided by 2. Now if you pass an even number, then we're doing something that we did not expect. So let's add an assert that n is even, odd I mean. I think the compiler will change that to a bitwise end. No, okay, let's make it sure is odd. Well, might also want to go back, so that would be number index to number, the other way around. Now that's the inverse of this, so that's 2 times I plus 1. Don't want to do too much on one line. So let's convert. This is then a number now. No, wait, I want to run over, forget that. So I just really want to just run over all the indexes. Now we start at 0 though. I just do more or less to 500,000. Why not? But let's convert it to a number first. So that's index to number, then I. And now we calculate the number of steps. So now I have to implement the number of steps in steps, which takes a number. But the number is going to be odd. Calculate the number of steps required to bring the odd integer n to 1. I'll explicitly add to it that it must be a positive integer. Okay, I'll add an assert again. It's a waste of CPU, but okay, so then we do n becomes 3 times n plus 1. That's what. And then you have to divide by 2. So n shift left, shift right actually. And the number of the number of zeros on the right side. What is that called? Probably have that in util somewhere. Yeah, I'm just gonna bring in my own code because I'm crazy not to do that. So git clone. There's a bit of work though. Already spent 10 minutes, 12 minutes on this so far. But I do need utils. Just gonna clone my utils. I need it. github.com utils.git, or is it called AI utils? What have I been doing wrong? Nothing. Username. I must be crazy. It's called AI utils. Shall I use this? Okay, I might as well use that, I suppose. Well, at least now I have utils here. Or not. That doesn't look like utils at all. Utils. There we are. MSSB. That is most significant something bit. Count trailing zeros. That's the one. I think. Returns a count of trailing zeros if in n, the index of the least significant set bit, undefined when n equals 0. Yeah, that's what we need. Utils that. Yeah, that should remove the all the zeros. Now, it cannot be very fast because you have to do this 500,000 times, which I totally don't like. Oh. Something is wrong. Because it should print stuff very quickly too. So 1, number of steps should be 0. And then we get again 1. Okay, the plus plus 1 here is missing. Oh my god, yeah, okay, so let's increment my I. That finished very quickly, but it didn't print anything. But it finished very quickly. Why would this number of steps never be equal to 2? That's of course impossible. I mean, am I not incrementing the number of steps? Wait, I'm not incrementing the number of steps, I think. Yeah. Steps. Finally, and that looks good. These are indeed the numbers that are that go back. That need 2 steps. So it's fast enough not to even have to write it to a file or anything. Can just reproduce this every time. Well, can make it even faster by compiling it with some optimization, I guess. 33 milliseconds, and it printed stuff. Okay, having done that, what I really wanted to know, let's not print this anymore. What I really want to know is let's think. I want to have a vector with numbers that are probably not totally this must be all the positive odd numbers, integers, I mean, that go to 1 in 1 step. And have a modulo are equal to 0 modulo 3. No, I'm not even interested in that. Equal to 1 modulo 3. And the same thing for 2. And I'm going to generate them as follows. Well, this is a vector. Let's make it a capital K, as in it's a set. Fucking K. Let's make the first K that is that goes to 1 in one step and is equal to 1 modulo whatever. No, the smallest integer that goes to 1 in one step equals actually it is just simply it is a difficult formula, but I don't believe that there's a reason to calculate it. Originally it comes from I think 1 times 3 plus 1, and then that happens to be 4, so can divide it by all the power of 2, so divided by 4, which is 1 again, and then we have to multiply it by 4 and add 1. I mean, that seems like a nonsense talk, but this is the essence of how we find it. However, this is 1 and 4 plus 1 is 5, so I might as well just set it to 5. And of course everyone knows that 5 is the smallest integer that goes, that the smallest odd integer that goes to 1 in one step. 5 times 3 is 15 plus 1 is 16, divided by the power of 2 is 1, so 1 step. Then we can generate all the numbers. What I'm going to do is I'm going to do while something. Let's say let's say int the mods count. I want to find the first number of this one and of this one. And I do that as follows. I'm going to say if k1 modulo 3 equals 1. And then we do this. Push back. K1. And if it is equal to 2, and I push it to that other vector. And this means we have one of them, and then in this case we have the other one. So while mods is less than 2, right? So as soon as it equals 2, we have both of them. It is also a possibility that it is equal to 0, but we are also not interested in the numbers that are equal to 0 modulo 3, because if I prove the Collatz conjecture for all odd integers that go to 1 in s steps and are equal to 1 modulo 3, and I prove it for all odd positive integers that go to 1 in s steps that are equal to 2 modulo 3, and then I already proved it, because the only odd integers that are done missed are the ones that are equal to 0 modulo 3, and if that is the case, then it's an odd number. I mean, this is just a proof here. So suppose you have a number k for which holds that k is odd and k modulo 3 equals 0. Then the Collatz conjecture says, well, let's first find the general form for that. This means that it is a power of 3. So that means that k is 3 times something, right? So this modulo 3 is 0. And it must be odd, so that means that it is 2n plus 1. This must be an odd number, otherwise it's k is not odd. And then, for n is larger or equal 0, which means that the smallest number is 3, so we skipped 1. No, we skipped 0. Yeah, we don't want that. This is good. 3 is the smallest such number. And then the college conjecture says we have to multiply that by 3 so that you get, so this is actually, let's fill it out, maybe it's nonsense, but that will be 6n plus 3. Now I have to multiply that by 3, so k goes to 3 times that, that's 18n plus 9 plus 1 is 6 times 3 is 18 and 3 times 3 is 9. Sorry, not that 3, but the 3 that we have to multiply with for the Collick's conjecture. And then add 1, so that would be 18n plus 10. And then we have to divide it by 2 until there are no 2's left. So here we have 9n plus 5. And no matter what n is, this number here might have factors of 2 in it. So this is 2 to the power something. Maybe. Times something. I don't know, times q. It's possible, but, and then I have to, q does not have any powers of 2. And then that goes to q, right? However, I can already calculate the modulo 3 of q, because the modulo, well, actually that's not true. Yeah, well, okay. The modulo of I mean, this is unequal 0. So guaranteed. Because the modulo 3 of this is 2. This is divisible by 3, and this is not divisible by 3, so the modulo 3 of this number is 2. And if then you divide it by 4, it doesn't change, because the modulo 3 of 4 is 1. So it stays at 2 for every power of 4, and then maybe if L is odd, it changes to 1. So you can say that this is 1 if L is odd, and 2 if L is even. Therefore, if I prove it for all positive odd integers that are unequal 0 modulo 3, then I have also proved it for all odd integers that are equal to 0 mod 3. Because it's just one step, and you have you lost it's no longer equal to 0 mod 3. So therefore we are not interested in values that are equal to 0 mod 3, because they automatically fulfill the College conjecture anyway, if we prove it for the ones that are equal to 1 or 2 modulo 3. Now I'm in this loop here where I'm doing something with k1, so I have to change k1. Big trick, k1 becomes 4 times k1 plus 1. Shall I explain that, or is nobody listening anymore? Let's see. I've predicted that the number of... Oh, still 21 viewers. Amazing. Okay, so the reason for that formula is as follows. If you have a number k that goes to, let's say ks, that goes to 1 in s steps, then you can derive, you can find another k s plus 1. Let's do it in a LaTeX notation. By multiplying with some power of 2 and then subtracting 1 and dividing that by 3. Because after all, if you have this number and that number is odd, then you have to multiply it by 3 and add 1. So then you get this number. And then you have to divide all the power of 2's away, so that you get this odd number. So this one, after one step, becomes that one, if this equation holds. So this equation can only hold if this is divisible by 3, which means that this must be equal to 1 modulo 3. Because this is equal to 1 modulo 3. And if you subtract that, then the whole thing is equal to 0 modulo 3, which means that it is divisible by 3. And the only way that this is equal to 1 modulo 3 is when, well, it depends on the modulo value of ks. If ks is a modulo 1 3, then this must be a power of 4. And if ks is equal to 2 modulo 3, then you must add an extra 2 in here. So let's first look at ks equals 1 modulo 3. Then what does this mean? Well, oops, if this is true, you can just multiply this by 4 on both sides. Sorry, I meant you can just multiply it by 4, so it set n to 1. That would be the smallest number, the smallest such number. You cannot set n to 0. This is not working. Then you just get... so that number is not working. You must multiply it at least with one factor of 2. Otherwise it's not odd anymore. The result. Let's not get into that. So if this works, and then the next number is squared, and the next number is to the power 3, and so on. Yeah. So we have this number, and we want to find the next number. So I multiply this by 4. Now I multiply this by 4. So now I get here my power of 2, and this is also multiplied by 4. So I just multiplied left and right by 4. And now note that this is equal to that number, but then I have the a 1 here instead of a 4. So really we wanted to have a minus 3 here as well. But we can put that after that, because minus 3 divided by 3 is minus 1, so that's the same thing. From which follows that 4 times ks plus 1 plus 1 equals I'm doing something wrong. It's the other way around. Forget it. I did it wrong anyway. I'm doing it wrong, but this is the formula. And the reason was more or less that. Okay, so this loops over all this all the numbers that you know, depending on that on the power of 2, the possible powers of 2. Let's put it that way. So afterwards we have exactly one element in this one. And one element in the other one. And let's print them. And now this one we already know, that is 5, and this one is going to be 85. Yep, 85 and a 5. And then the power of that is that now we have that. I can just fill these vectors in. Let's make a while loop. So I'm going to set my K1, I already have that defined. K1 equal to that one number which I just printed, and now we do it like this. And then while K1 is less than 1 million, and then we have all the numbers that are unequal 0 modulo 3 and go to 1 in one step. So I guess you can print it. To type. I really can't type. Is this oh no, that's just copy paste. Yep, that doesn't look good at all, because this is 0 more. Yeah, that's nonsense, of course, nonsense. Sorry, I have to do that 3 times in a row. So I have to do this 3 times in a row, which means that actually I need to do times 64 plus What was that number? 21, I think. Let's not be too lazy. Okay, so we have k, and now we have 4k plus 1. And then we have times 4, so that's 16k plus 4. Plus 1 is 5. Yeah, it's 21. So times 4 is 64k plus 4 times 5 is 20 plus 1, 21. So now you see that, well, it printed out all the numbers that go to 1 in one step. And now we have 5, and then we just skip 1, 2, 3, and 1, 2, 3, 21,000, and so on. And this one also skips 3 every time. It doesn't because it didn't fix it. Grr. So I don't understand what you're saying now. Make me worried that my audio is bad. Oops, that's not what I meant. This thing. My audio is still good. Okay, no worries. No, it's not helping, Omnic. Find 3, but not much. Damn it. But I can hardly make it larger. Maybe I can add one more digit. I mean, it was milliseconds now. Let's add one more 0. Yeah, well, we got a whole number extra. I'll add another 0. Yeah, I don't want to have to wait this long every time. We could do up to 23 million, and then at least have the same values here. 25 million. Reasonable. Okay, now Yeah, it's not even interesting, those numbers. The smallest one are more interesting, the smallest ones. So now next I want to do the same thing, but then for K2. Now we have to begin with the minimum. The minimum value that we found before, so that would be the minimum of the first value of K1, 1, 0 and K1, 2, 0. So the minimum is an algorithm or something. And then we do exactly the same thing for K2. In other words, I could write a function for that. I'm going to, I guess. Yeah, so after that, this is also true. And let's generate all of them and print them. It's just doing exactly the same thing. Again, really. Okay, and then the question is this still correct? Yes, it is still correct. Now, let's compile that. Redefinition. Not correct. What happened here? Yeah, the standard minimum is not good. I need a minimum after converting them to, well, might as well take the minimum, but I have to do something with it. Let's see, what? Yeah, this must be multiplied by 4, subtract 1, and divided by 3. And this one must be multiplied by 2. Yes. Minus 1 divided by 3. Nah, semi-correct, but I'm missing the 3. Why? 13. Let's check if this is indeed in 2 steps. Well, that's why I did the other one, right? So, so yeah, it's correct. Like 13 times 3 is 39 plus 1 is 40, divided by 8 is 5, and 5 is here. And 53 times 3 is 159 plus 1 is 160, divided by 32 is 5. That's not correct. One of them should come from 85. What the hell is that? Oh, I have 2 of them. Yeah. I found the minimum one, that was 5. And then this is the modulo, this is 1 modulo 3 and this is 2 modulo 3. But both come from the 5. We have 2 more that come from the 85. Or do we? Because, what about then that one, etc.? Actually, all of them, but I'm not that interested in those, am I? I guess the reason I am not finding the 3... Why am I not finding the 3? 3 times 3 is 9 plus 1 is 10, divided by 2 is 5. I should have found that. Why are we not finding the 3? Oh, we're not finding the 3 because 3 is equal to 0. Modulo 3. So it just skipped. Yeah, probably you get 5 times 4. I think 4 times 5, 20 minus 1. What? 5, this one. 5 times 2 is 10 minus 1 is 9 divided by 3 is 3, which is then the minimum. So K2 becomes 3. And then the modulo is equal to 0, that's skipped. And then we get 3 times 4 is 12 plus 1 is 13, which is then added. And then the next one is 13 times 4 times 13 is 52. Plus 1 is 53. Yeah. But really, I guess I should have done this for both of them, not just the minimum. Was that does lead to different values. In other words, I need this to be an array of vectors. Anson Gaming, yes, I'm it's clearly doing that. Again. I really don't like it. Let's just call them without the underscore m. And then I'm calling this one the modulo 1. And modulo 2, as in modulo 3 equals 1 and modulo 3 equals 2. And let's make an enum. No, it's not really an enum. But a const int m1 equals 0. Hmm? That I do not get at all. Yeah. 6. Yeah, okay. Yeah, that deleted the other one without thinking. There we are. So this is the same output as I had, and I also have the output for 85. And we can put all of this into, I guess, a function. Yeah, now this number is also growing, so it cannot be an array anymore. It has to be a vector. Let's make this a vector. Of size 4. Now I want to make this first block and the second block a function. And then what goes in and what comes out. I think that what comes out is this vector. The vector of vectors. And what goes in is the previous vector of vectors. Isn't it? I think so. because we're printing it eventually just having K2. So all of the above can be replaced with auto K2 equals, how do we call that? I'm gonna call it generate fill. Next step, whatever. Now we're passing, let's say K1 for now. Oh wait, that was inside the loop. Yeah. I'm gonna return this. And this is called next step. We also got that as input. And that return value, this is a return value, so that's basically the result. And we're gonna call it KS. Now let's call it K2 next. Yet, gonna rename it later. This 4 is, yeah. So I'm doing this loop now without printing anything. And then I want to print it afterwards. I think this should work. Yeah, okay, let's keep it simple now and just use the same names until it works again. That works again. Now what I'm passing here is K1, which is the size of 2. So I'm pretty sure I can replace this 4 here with 2 times K1 size. No, also K1 size. Something is not right at all. Got to be 2. Of course, trying to find a way so that if I pass K2 to this function, we're gonna get K3. I think I just have to do, let's say, everything for each element. It must be K1 size. Okay, if we do it like this, then we have every other index is the modulo is 1 or 2. Modulo 3 is 1 or 2. Which means that rather than checking if it is 0, I have to check if it is even. I might as well print it inside that function as well, I think. Two times m, where does that 2 come from? No, that's correct. At any rate, there's still this still works, I think. Horrible music. can we replace this block also with, sorry, the block here, this block also with that function? The problem is that we only have that it would be, you know, we have to pass a case 0 basically, and the function is assuming that we always have a modulo 2 as well. I'm saying it wrong. Modulo 3 equals 2, and we don't. Case 0 is just 1, which is always equal 1 modulo 3. And I could call the function if I added a test and stuff, but it seems a bit, yeah, just making it more difficult. I think I'm gonna put K1 outside of it. I'll keep it outside here. Although it's a lot of code duplication. All of this, including the printing. But hey, let's do the next one. And that goes wrong because I'll have to start with renaming this. Let's rename K1 with KS. And K2 with yeah, KS plus 1. Horrible, I know. Yeah, this is not working, of course. It's expected number of steps. So that must be S plus 1 then. How do I know what S is? The rest should work. S is again derived from the size, I guess. So when this is just a log 2, the log 2 of the size of this one, or I think so. Size, okay, 2 at the size of 4. Okay, 1 is the size of 2, so yeah. Thank God that worked. I actually calculated this from my head. I recognize that number, I think. I don't think I got any further. Okay, so let's print the number of steps. Now the big question is, did I not miss any? So now I should run over all the things that I brute forced in the beginning. And then see if these are all of them. How do we do that quickly? Nah. I think my missing is wrong. This should be the one that goes to 1 in a single step. That's not 7. 7 times 3 is 21, plus 1, 22, divided by 2 is 11. Not 1. Why is this being printed? I don't understand it. Yeah, so let's print it on in GDB. The first check. Gives me worry. Okay, forget it. What the fuck? So this is modulo. This is equal to. Oh, I get both of them. Yeah. This is all the values that go to 1 in a single step, and these are modulo 3 equal to 1, and these are equal to 2 modulo 3. And now it's going to say that it is missing 7. Nonsense. The first number is 1. No, I don't really want to do that. I want to skip 1, I thought. 1 is 0 steps. What is steps? Print steps 1. 0 steps. Sorry, I? That's nonsense. I is 0, so I must print 0 is also 0 steps, but then steps 1 should not be 0. What? Or is it because that is 3? Yeah, okay. Yeah. Anyway, next, K. Print K, now we have 3, so we kept this, and now we go print K, now we have 5, which is not missing, so we might as well do continue. I'm really surprised why we didn't test anything yet. Might as well go for the 7 though. Print K, 7, okay, not 0. Print I is now 3. Print steps 3. 1. Yeah, that's nonsense. How do I get here? Why is steps 3 equal to 1? This fills in index 1. index 2. And now comes index 3. Oh, so index 3 has is actually equal to 5. Now this is index 1. Wait, wait. That's wrong. 143. Still not working, but it's only, yeah, this works, 2 works, no, 2 doesn't work. It says that 227 is missing. Two two seven times 3 plus 1 divided by 2. 341. Yep, that is indeed 2 steps. Oh, that's the reason. Yeah, okay, I get it. I'm only finding the ones that end on 5 or 85. So these end on 85 and these end on 5 after 1 step. But we are not finding the ones that end on that or that and so on. And that's then the ones that are missing. Let me try that one for fun. 149, 130, 77. Yeah, times 3 plus 1 divided by 2 divided by 2 divided by 2 divided by 2 divided by 2. There's 1398101. 1398101. What's this 3 doing here then? Oh, this one. Whoa, that's a coincidence. Holy moly. That's a pretty big coincidence. Or is it? It's probably not. It holds for the whole thing. If you multiply by 10, add 3, you get that one. Amazing. And that one times 10 plus 3 times 10 plus 3. This is 1 times 10 plus 3. Oh boy. I guess the same thing holds for this. They all end on 3. It's time to do. Now we see the pattern in these. It's not coincidence, they all end on 3, but I don't see the... How do I get from one of these numbers to this? Probably 113 would be... Probably then from the 5. Good, times 20. 5 times 20. And then randomly plus 10. Or it's plus 13. That's it. Times 20 plus 13 maybe. So 85 times 20. Nope, that didn't work. Just 18, 13 modulo 85. Looks like 21. 85 times 21 is 1785, so subtract that from the 1813, I get 28. That's a weird number. $85 times 21 plus 28. 5 times 21 plus 28. Nope, that doesn't work. Five, 4, 6, 1 times 21 plus 28. Also not. Oh well. No, very closely related though. They not all end on 3, they all end on 13 or 53. Thirteen, 13, 13, 53, which is also 13 of course, but then plus 40. And here also 53, 53, 53, 13, 13, 13, 53, 53, 13. Don't tell me that it's a coincidence. It's not. Totally not. Well, the coincidence is that apparently something has to be added after multiplying with something that is divisible by 10. Looks like it. Or it's something else. I don't know. I think I'm going to bed. Let's just add one more. Check is... the check has succeeded. I think it kind of finds everything, but yeah, only the small numbers. Wait, 3. Yeah, no, the reason I was mostly interested in this is to see the really small numbers. Like 11, 23, as long as it really stays small. But then again, there's some of these may come from already pretty large numbers here. Although, not super likely, because you just have to multiply it by 3. For example, the 11 times 3 plus 1 is 34. So that's not large, and you have divided by 2. That's 17. So this 11 comes from the 17. So it's always, yeah, smallish. It's related to smallish. 17 times 3 plus 1 divided by 2. Again divided by 2, 13. So the 17 comes from the 13. The 13 comes from the 5, I bet. Or no. 13 times 3 plus 1, yeah. Comes from the 5. Or goes to, rather. And then this 23. 23 times 3 plus 1 divided by 2 it's 35. 23 goes to 35. Okay, I'm lost. This one goes to 106. How is that possible? Oh, it's divided by 2, idiot. 53, yeah. Right then. Hey, Ensign Gaming. Yep. I should have been in bed like at least an hour ago, so I'm gonna stop. I'm not sure if I have new food to think about though now. Not really. Well, maybe, it's just for fun to fall asleep. So maybe you can think about in bed why this ends on 13 or 53. It would be possible to figure that out. Everything that ends on 5 or 85. Nah, it's probably the 5 here. I mean, come on. It's got to be easy. It's kind of scary, You do this times 64 and then add 21, and you get again something that apparently that alternates. So yeah, it's 1353, 1353. So we do that twice. I'm having something that doesn't change the modulo 100 for some reason. Really. So this something times something that modulo, so yeah, something that is equal to 13 modulo 100. And that's something then times 64 plus 21, and then again times 64 plus 21 is again a number that equals 13 modulo. Is a number that equals 13 modulo 100. Or we just do it once, you get 53. So the 53 changes into 13 and 13 changes into 53. The modulo 100. If you multiply it by 64 and add 21. I'm going to think about that. It's just that while I fall asleep. I believe that the stream is again lagging like absolutely insanely. Because if I watch what I see here, is not even, it's like 15 minutes behind at least. Holy shit, that is much behind. That is ridiculous. Yeah.